see. Yeah, how come so long? Okay, so O is the circumcenter of ABC. And then we draw the perpendicular. D is any point on the circumcircle. This should be O. And we call this point D. And then we draw the perpendiculars from D to OA, OB, and OC. And we want to show the incenter of that triangle lies on the Simson line, corresponding to point B. Okay, so let's see the best way to do this. I'm going to try to make a nice diagram. Where should I put D so that it makes the best diagram? Is there a good spot? Kind of like that. All right. So this problem is a really hard angle chase. The last problem or this one? Oh, this one. I'll see what you can get. So let's do it like this. So we have BO, CO, and AO. I'm gonna draw some more rays. So actually, let me. I want it to intersect both BO and CO if possible, kind of like that. Or actually more like that. Okay, so yeah, I like that. Okay, so this will be X, Y, and Z. And then we draw the perpendiculars from D to AB, AC, and BC. Okay, so we want to draw the incenter of XYZ. And let me draw the Simson line. As we'll draw all three perpendiculars. Okay, so that's the Simson line of D. And then if we draw the incenter of the XYZ, there we go. So the chat, it says, do a homothety with ratio 2 and prove it lies on the Steiner line. All right. First, let me make the diagram a little nicer. Whoops. So we have this and this and this and this. And then it's probably also worth trying this. dxoyz we know is cyclic. The points will lie on the circumcircle of ABC. So, oh, because since these are perpendiculars, yeah, okay, so let's do that. So homothety. So homothety with ratio 2 takes this circle to this circumcircle. So, okay, so this, we'll call this y prime and z prime. And this is x prime. And is the Steiner line, so if I draw the orthocenter of ABC, okay, so what would the incenter of x prime, y prime, z prime be? So I could just reflect d about h. Oh, whoops, I want to reflect about a point. Sorry. So basically, if I reflect d about h, I want to show I d. So what's a better name? This is supposed to be the orthocenter, so it shouldn't be I. We want to show kd prime is parallel to EF. I think that would solve the problem. Okay, I'm confused actually. It almost looks like these three concur, but I don't think they do. Because but yeah, I think if we could show so is the Steiner line the parallel to the Simson line, but through the orthocenter? Yeah, there's a lot. Let me know if you want me to erase something. Like, should I erase the homothety? I thought it might be useful, but
homothety might be useful, actually.
Okay.
Maybe we can delete segments dy prime. Not, yeah, dy prime. dz prime.
Oh, draw those or delete? Draw dy prime and
Delete, yeah, delete.
delete it. Okay. So okay, X, Y.
Actually, we can need x, y, z if we use homothety, so we can delete them. We can use x prime, y prime, z prime.
Okay, so basically, we'll just use x prime, y prime, z prime, and then we can kind of delete x, y, and z, right?
Yeah.
Okay. So, yeah, I don't think we really need x, y, z, or this circle. Well, we could keep them. We just don't need the segments. Like,
And also the little circle.
So yeah, we just want let's see. So let's draw the incenter of x prime, y prime, z prime. Well, actually, yeah, we can still have that there. It's just, okay. So should I draw this like?
We can delete the Simson line and draw Steiner line.
What's the Steiner line? Is it through the orthocenter?
Yeah, through the orthocenter and parallel to Simson line.
Okay. Okay. And then I want to draw the in circle of x prime, y prime, z prime, right? What was that called? I'll just use this. So yeah, I want to show that that lies on the Steiner line. Are there any special properties of the Steiner line? I don't know too much about it. So is y prime z prime parallel to BC? Not sure about, no, it's not. You can make some of the segments then. Oh, like, yeah, so. Oops. Oh, I was gonna say like draw, oh, just make them thinner. Um, so which segment should I make thin?
dy prime, dz prime, and dx prime.
Okay, these three.
Yeah.
Um, is it style? Make it like a 2. And then this one. Is that kind of what you were thinking?
Yeah.
Okay. Okay. All right. So what do we know about the anti-Steiner or the Steiner line? Is there anything special about it? So I guess as we move D around, the incenter would yeah. So is it a coincidence? All right, see you, Con. Thanks for your participation. So what's true about the Steiner line? I just don't know much about it. Like how would we use any, like what's a property of the Steiner line besides the definition?
Just know that it is through orthocenter.
Okay. So just the definition of it. So yeah, we want to show IK is parallel to the Simpson line. That's an interesting problem. let's see. B, A, and C are the midpoints of arcs.
Can you reflect B across BC?
Reflect A across BC?
No, D.
D across BC. All right. Oh, it looks like it might also lie on that line.
Actually, the definition is the reflections of B, the definition of Steiner line, and orthocenter is on it. So we want to prove that these three are collinear.
Okay. So if I can prove those three are collinear, that would solve it.
Yeah. Also, can you delete the line?
Yeah.
3 points.
Let me just call this D prime. So Geo King was saying B, A, and C are the midpoints of those arcs. So basically, can we say anything about the incenter dy prime z?
This is D prime, I guess.
Okay, so it's like D prime is incenter. Good point. So those are collinear, and these are also collinear. Do those concur on AX, or is that just a coincidence? That's a coincidence. So yeah, arc AD is equal to arc AX prime. So let's see, angle bisectors.
Yeah, can you draw DD prime and X prime I?
Sorry, DD prime and
As lines. They will intersect on the circle ABC, circle of ABC.
oh, okay. Hold on 1 second, guys. All right, thanks for waiting. Sorry about that. So I see one other person joined. Thanks for joining. So maybe introduce the midpoints of x prime, y prime, and x prime, z prime. Okay. These two. JLM is similar to ABC. I wouldn't be surprised. Let's see. $63. Yeah, it looks like that's true. Yeah, to show that JLM is similar to ABC. Yeah, I would think that's probably an arc chase because Yeah. If they're similar, though, they're congruent, right? Well, actually, no. Well, wait, actually, now I'm not sure it is true, because if they're similar, since they're in the same circle, they would have to be congruent, right? Unless they're like reflections of each other. Oh, they are. They're like they're congruent, but they're just not oriented the same way in the circle. Sorry. The orthocenter of JLM. Yeah. I think it is I. It looks like I equals the orthocenter of JLM. So I don't know if that just solves it, because we have one orthocenter, we have another orthocenter. So does that solves it? Or and so those two orthocenters, basically by symmetry Kn should be parallel to AJ. I wonder if AKB prime J is a parallelogram. Yeah, it looks like it. It looks like AKD prime J is a parallelogram. Is that obvious? Because AK is twice the distance from O to BC, and I think also, yeah, so AK is twice the distance from O to BC, and J, if N is the orthocenter of JLM, then JN is twice the distance from O to ML, which would be the same thing. So, well, actually, since the triangles are congruent, it's automatically the same. Yeah. So, yeah, we just need to show that AKB prime J is a parallelogram. So I think we're close here. But AK, because D prime is the orthocenter of JBC. Yeah, so yeah, so it is a parallelogram. So okay, I'm going to start writing this up, because I think we have a solution. So I'll say let D prime be the reflection of D. So let K be the orthocenter of ABC. let dx, dy, and dz meet the circle ABC at at x prime, y prime, and z prime. And let d prime be the reflection of d over BC. And let dd prime meet the circle at J. Then that proves that d prime is the orthocenter of JBC. So we get that. Because the reflection of the orthocenter over the side lies on the circumcircle. We also have JD. So JD is parallel to AK, that's obvious. And also JD is twice the distance from O to BC, which is AK. So yeah, we used the same idea last session. So JD is twice the distance from O to BC, which is AK. So AJD prime K is a parallelogram. And then also we could show that AJKN is an isosceles trapezoid because triangle JLM is similar to ABC. So I'm going to define L and M. So how did I define those? So I forgot how we defined L and M. Let's see. One new message. L is the midpoint of arc X prime, Y prime. Okay. That's right. Let L be the midpoint of arc X prime, Y prime. So then we try to show JLM is congruent to ABC, which is an angle chase, because let's think about this. So that would be the same as saying So first of all, we want to show that do we need to show this? C, D prime, and Y are collinear. So I'll say let n be the incenter of x prime, y prime, z prime. So we want to show that n is actually the orthocenter of JLM. But okay, so that follows. So these two imply that n is the, because we have that j as the midpoint of okay, so first of all, by the incenter x-center lemma, d prime is the incenter. Okay, so d prime is the incenter of d y prime z prime. And from there, it's easy to see that
ln equals lx dash by incenter center lemma.
L, say that one more time.
ln equals lx dash.
Ln equals Lx dash.
ln equals lx dash.
Okay, so basically,
And similarly, mn equals mx dash. So lm is perpendicular bisector of x dash n.
okay, so but ultimately, whoops, sorry about that. Like, we just want to show JLM is congruent. So we want to show that N is the orthocenter of JL. Okay, so yeah, so hold on just a sec. Okay, so ML is the perpendicular bisector. Okay, so I'm gonna write what you just said. Ln equals Lx prime. Sorry. Ln equals Lx prime, and Mn equals Mx prime implies ML is the perpendicular bisector of Nx prime. And once we know that, then we know that N is the orthocenter of JLM. And then, and I guess I'll just say by an angle chase, JLM is congruent to ABC, because that's really, I don't know if there's a more obvious way to see it than an angle chase. Yeah, I just know we've done this for a while, so. So that means they have to be congruent since they're in the same circle. And that means that AK equals JN. And then once you know that, then that means ANKJ is an isosceles trapezoid. Or AJNK is an isosceles trapezoid. And that means that D prime K and N are collinear. Because we knew that that was a parallelogram up here. And then once we have that, so I'll just start writing out stuff up here, but I'll just say by a homothety about D with ratio half, the incenter, yeah, basically I could just write the conclusion. By a homothety about D with ratio 1/2, the incenter of XYZ lies on the Simson line of D. All right. Looks good. So yeah, sorry, it took me a little long to write that out, but thanks everyone for your help on that. And I will move on to the next one. This problem looks a little tricky. Let me check the, oh, this one looks kind of interesting. Yeah, let's do this one last. So, so we have a point inside triangle ABC, and then we have its isogonal conjugate. So what I could do, so P is the point. What if I just draw the pedal circle? So there's the pedal circle. And if I reflect P over G, then I should get the isogonal conjugate. Okay, so this is Q. This is Q. And then I draw the circumcircle of ABC. And L, M, and N are the midpoints of those arcs. So it's probably worth drawing the incenter. Oh no. Are you sure you, if you need a study for your exam, you can go. It's all right. I think your English is pretty good though. But okay. All right. So, all right. So L, M, and N are the 3 points. Geometry is greater than English. I agree. I am very much in agreement with that. Oh yeah, they're pretty fun. So, so then we draw the circles PBC, so yeah, PBC, PAB, and PAC. So yeah, maybe I can hide. I'm gonna hide these angle bisectors for now. Yeah, let me hide. Yeah, there's too many lines. So, so then we draw the intersection of LQ. Okay, so basically we draw three rays and we see where they meet the corresponding circles. So LQ, MQ, and NQ. And they meet their corresponding circles at this point, XA. And then this point, which is XB. And then this point, which is XC. And we want to show that those are all cyclic. So it's kind of interesting. All right, so I'm going to hide the extra stuff. So you have MQ, NQ, and LQ. And let's just check that that's true. Yep, it is cyclic. This reminds me a little bit of the Hag circle. I wonder if there's like a special case. Because like if you reflect, I think if P is the orthocenter, then I think this is the Hag.
The Hag circle doesn't include P.
It doesn't have P.
Yeah, reflection, intersection of AP with ABC and three reflections.
Oh, you're right.
Orthocenter is on the circle of three reflections.
So it's kind of a different problem. Yeah. Okay. So was Q also on the circle? I forgot. No, Q's not on the circle. Yeah, this problem's scary for me. I don't know too much about isogonal conjugates. It could be an angle chase. Is there some other point that lies on the circle? That's some special point. Yeah, I don't think so. Yeah, I'm not sure. This problem looks hard to me. So yeah, what are some, let me see if I have some random idea.
Maybe ABC is similar to XA, XB, XC, or LMN is similar to XA, XB, XC.
Ah, that could be. Ah, so close.
Can you also check the other angle?
Yeah,
Right angle, I don't know.
yeah, let's check all three. Whoops.
Okay, it's not.
Yeah. But yeah, I feel like there's a lot of questions where you have like this circumcircle of PBC, and then you have like something like sometimes it's like where does AQ meet that circle? I don't know. Yeah, I feel like there's a good amount of theorems on that. I just don't know them that well. You want to try the problem before this? I think this one's kind of hard. It's up to you.
We can try this actually. This is beautiful.
We can try what?
We can try this problem.
Okay. It almost looks. Yeah, I'll try this one for like 10 more minutes and then I'll switch to the previous one. Maybe there's some kind of homothety about P. Because yeah, G is the midpoint of PQ. Maybe something happens if we take the midpoint of.
Can you check that if center is a special point?
Oh, the center of that plus. Yeah. So H. Let's see. Could H be the? I was thinking maybe the incenter, but oops, sorry. Oh, maybe X, C, H and that point are collinear. I don't know if that's a coincidence. Whoops. Let me move the diagram around. Yeah, it does look true. Oh no, it's not true. The circumcenters of, yeah, let's see. Oh no, that's not right. So HN is a perpendicular bisector of PXC. Oh no, is that true? I don't think so. It's a perpendicular bisector of AB. IM. So yeah, I mean, these three lines would pass through the circumcenter of ABC, right? Okay, I'm going to click the link Serdar just showed.
This is what I3435 showed us.
Okay.
Actually, this is not related to our problem, but I just want to share.
Okay. It's like a property of like isogonal conjugates, basically, and orthocenters.
Orthocenters and isogonal conjugates.
Yeah, I remember this. This is the one you showed last time. So yeah, this property gets used a lot, it seems. Do you guys want to go back to this one? I feel like we're close on this one. All right. So yeah, RA is parallel to B1 prime B2. Sorry, is that right? Yeah. And then also So yeah, we want to show that RA, RE, RF, RB2 are in harmonic conjugation. What if we looked at it? What if we said, I wish I could project through point E instead of R. So we also know that B1 prime, F, B2 prime, and the point at infinity are in harmonic conjugation. We could try projecting through B. I think we kind of already tried this. So then we would get ACHB is harmonic. And that's kind of, yeah, that's kind of obvious. But can we take those points? So yeah, what do we do with point F? Let's see if there's something special about the line RF. Does it intersect anything? Yeah, we tried transforming it. I think our transformation was good. But yeah, I'm just not sure how to finish it off. So you have the perpendicular from A to BO, and then we have the foot of the symmedian, and then we have the anti-parallel through the symmedian point. And we want to show that those are linear. I don't know if there's a way to redefine things. Can we show that angle? Like, let's see if we can use this circle a little bit. What if we let this intersect the circle at a point? Is IH tangent? That would be interesting. Oh, it looks true. That would be really interesting. I think it's true. Oh no, it's not true. Oh man, that was so close. Is there anything else we can say about point I? Maybe IO is parallel to AB. That would be interesting, but that's not true. And maybe there's a better way to define B1 prime. So yeah, a homothety about C takes C A1 prime B1 prime to C AB. Can we say anything else about that homothety? It takes J to F. What if so actually, now that I think about it, so that homothety is going to take this circle to the whole circumcircle, and this line is going to be tangent to both those circles, right? X, Y. And yeah, FA1 and FB1 are going to be tangent to this circle. Right? So these are both tangent to that circle. And the median point is going to lie on this line again. So yeah, we could instead think of this as the tangent to this circle. Well, whoops. These are going to concur. Are H, L, and X linear? I don't think so. C, no, we kind of defined, so we kind of redefined these points so that it would be cyclic, but like the original A1 and A2, we haven't proven that it's cyclic. So basically, we defined A1 prime and A2 prime so that that would be cyclic, but we don't know it for the original A1 and A2. What would the generalization be, I guess?
Intersection D can be any point on BC. We assume that it is the intersection of AC median and BC, but D can be any point. And we similarly define A1, A2, and we see that CA1, A2B is cyclic.
Okay, you said D can be any point?
Yeah, D.
Okay, so
We define A1 as intersection of.
but
We
this
won't
wouldn't
get
be
rectangle. We will first prove this lemma, then we will take D as a special point.
okay. I think I deleted D. That's why I was getting confused. But D is this point right here, right? So, yeah. Okay. So we start by letting D be any point on BC, and
Can you
then
draw another diagram from GeoGebra?
yeah, I could draw another diagram. So, okay. So D is I'll draw it like this. So from B and C to AO. All right.
Can you make A on the top?
Yeah, I can do that. Okay. And then D is any point on BC. And then what's the next step? Draw the draw the altitudes from BC to AO, my bad. All right.
Now intersect DE with AC and DF with AB.
All right.
Not B, actually. You named it wrongly.
Oh, whoops, it should have been this. Yeah, you're right. All right.
BCGH is cyclic.
BCGH. Ah.
We can prove this by proving GH is equal to AO.
Okay, I did not know this. So if we go back to that problem, basically you're saying, whoops, which one was it? This one. So just by the way things are defined, okay, so we know this is cyclic. So I guess we want to see it as the converse true. Like, so yeah, maybe I just need to start over with this But like if we know this is cyclic, then does that mean, yeah, I'm trying to think. It's an interesting lemma though. Yeah, so like we redefined a bunch of stuff, but maybe it's best to just like start over and like draw the diagram the way it used to be. Okay, so like yeah, so then we would know that, yeah, it's just a little confusing, like what we want to start with. So like if we define it the way we did here, then see, so this is the foot from A to BO. So yeah, like maybe that would prove that RE and B1 prime are collinear. Yeah, let me like copy this. So oh, where did I put that diagram? Oh, right here. The spacing is going to be all messed up, but yeah. Okay, so you were saying D is anything, and then we're drawing the two perpendiculars, and then okay, so yeah, so that would prove that we have all these cyclic quadrilaterals, and if they're cyclic, then that would mean basically that these would be anti-parallel to the other sides. And running the altitude from D to EF might help. D to EF in this diagram?
No, other one.
Or the other one. Does it bisect EF? Not necessarily, because yeah, if you have it like this, it's not gonna, yeah.
Can you name the intersection of EF and the D altitude?
This?
Yeah, maybe we can use ratios because proving HG is perpendicular to AO is enough.
Yeah. All right, I think I'm gonna stop here because we're out of time, but this looks like a really interesting approach. So I will look at it further after the session. So yeah, if you guys find a solution to this, post it on Discord. I'm curious to see it. So thanks everyone for participating. And I know it's a pretty long session. And for everyone watching on YouTube, thanks for watching. So if you're interested in participating in the future, you can feel free to email me at mgreenb801@gmail.com. The sessions are on Sundays at 8 a.m. US Central Time. So thank you very much and have a great day.